Hi guys, I'm Louis Ding from Taylor's University, and in this video I'm going to further explain on center of mass to determine the center of mass of a discontinuous function on the Cartesian plane. Well, in my report I have stated 3 of the most important steps before you even determine the center of mass of that region. First of all, we have to determine x curl and y curl. X curl and y curl is the center of mass of the strips that we are bound to make out of the region, while dA is the product of times height times base. That's for step 2, and step 3 we determine dm out of dA, which is dA times the density. Well, here is an example that I wish to show you to further explain about this chapter. The question is calculate the center of mass of region bounded by y equals to 3x, x equals to 1, and the y-axis with density of 2y. Note that the density isn't a constant. So with that, we have to find x curl and y curl. X curl, the y curl, in horizontal method, y curl is always y. Because, take this strip as an example, you just go directly up here. So this is y. While x curl is here, is this part, this whole thing. So in order to find this part, it's 1 minus y over 3 divided by 2, which, well, in other terms, it is actually the midpoint of this region. But then 1 minus y over 3 over 2 is only here, and it doesn't include the x over here. So what we have to do is add the x here to this equation. So it becomes 1 minus y over 3 over 2 plus y over 3, which gives you 1 plus y over 3 over 2. And then after that, we find dA, which is, well, the sum of height and base. The height is dy, which is here, in between. And base is, well, this whole part here. So it's 1 minus the function. And with that, we find dm, which is the product of dA and density. Density, as you could see, is 2y. So, and 1 minus y over 3 is dA. So you get this as a dm to be integrated into mass. The people looking, but right. So over here, we is the way to get x bar. Well, as we know, x bar is the integration of x curl over here, and this is dm over the integration of dm, which will give you the mass. So after, well, we have, in this case, we have to do cross multiplying, and then we end up with 3 over 4 as the x bar. Well, it isn't as simple as it seems. Always remember, we are integrating in respect to dy, so the limit must always be in terms of y, which is 3 and 0. So that is it for x bar, 3 over 4. While for y bar, it's similar to x bar, but then it's the integration of y curl and dm over the integration of dm, which gives you mass eventually. So yes, similar to y bar, you integrate in respect to dy and use y-intercepts as the limits. So it's 3 and 0 again, just like x bar. And, well, you multiply the y in, and then, well, you do all the integration, and what you get is 3 over 2. So with that, I conclude that the center of mass of this region is 3 over 4 and 3 over 2. Alright, so now enough about question 1. That's a more simpler question, I would assume. So now we go to the second question. Determine the center of mass or region bounded by the curve y equals to 1 over 4 x squared, y equals to 4, and the x-axis. So over here, I sort of sketched the graph, how it looked like. So then, well, we proceed with the three most important steps, finding x curl and y curl. X curl, the sort of the midpoint of this distance here, which is square root of 4y, because we are doing it in terms of y. Square root of 4y over 2, and again y. So dA would be the whole area here, which is the base actually. So base is square root of 4y, and the height would be dy. And for dm, because as I stated here, the density is equals to a constant, which normally we call it a centroid. So then we'll multiply the area dA with a constant over here. We just leave it like that because there's no figure or anything to represent it. So now I'll proceed to finding x bar. So again, x bar is the integration of x curl and dm over integration of dm. Well, over here the limit will be dy in terms of y, so it's 4 to 0. And then what we got here is a square root. Well, in this case of integration, we have to sort of beware and focus on how we are to get rid of the square root. So, well, for the first one, it'll be easier. And as you notice down here, the constants will eventually cancel themselves out. So, well, you don't have to worry much about the constant. Yeah. There you go, it's gone. So, alright. Well, for the denominator in this case, it's quite complicated because we can't just integrate this part here right away. So what I did was the substitution method, which was getting u to represent 4y. So you get u over here in respect to du, not dy over 4. And with that, you have to beware to change your limits. Because previously, your limits are in terms of y, 4 to 0. But since then, you have used the substitution method. You are integrating it in respect to du. So, well, you just have to sub the value of the y into u, the equation that you have just come up with. So it's y equals 4, u equals 16, and y equals 0, u equals 0. So there you have, that is your new limit, 16 and 0. So, alright, the integration part will be simple over here. And we'll always remember to sub it back in, and you get a 3 over 2 for your x bar. So now the y bar, well, again, I have to repeat. Y bar is integration of y curl and dm over the integration of dm. Well, this way, since both of the numerator and denominator has square roots, we'll have to use the substitution method directly. So in that case, we sub this with the square root of u, square root of u. But how about the y here? Well, previously our equation was u equals to 4y. So then in that case, y is equals to u over 4. So that's how you get u over 4. So with that, you take out the constants here, 1 over 16, and then you multiply u and u to the power of half, you get u to the power of 3 over 2. And then the denominator is, well, like basically it's the same as x bar. So, well, always remember to change your limit again. Limit is 16 to 0 and not 4 to 0 because you are integrating it in terms of du right now. So after integrating, what you'll get is 12 over 5. Well, don't worry if you get a large figure like that because, well, eventually they'll cancel off since your denominator would probably be a bigger value or sort of there. So you end up getting quite a small value instead. And therefore, I conclude that the centroid for this region is 3 over 2 and 12 over 5.
So alright, hi again guys. This will be question 3, part 3 of the video. So I've decided to go with doodling for this question because I want to get in very detailed into the question and go part by part explaining how I got this variable, how I got this answer, because this question would be more complicated compared to the previous two questions that I've shown in my video. So alright, let's start. The third question is determine the centroid of area bounded by y equals to ln x, x equals to e, and the x-axis. So with the state of centroid over here, it gives us that density is equals to a constant. So alright, with these variables, we start by sketching the curve. The graph would be, as we have learned, would be something like this: y equals to ln x. So then e would be around here, and we should give you a value of 1 at the y-axis, because ln e is equals to 1. And then for the x-intercept over here, it will be 1, because ln 1 is equals to 0 over here. So there we have it. These two will be our limits. Alright, so now before we even start off with anything else, we wanna try to express the terms in terms of y, so that we can do the horizontal method by integrating in terms in respect to dy. So how do we do it is y equals to ln x. We ln both sides again. We get e to the y equals to e to the ln x. And with that, by the law of ln, we get x equals to e to the y. And there you have it. That's the main variable over there, the curve. Alright, so this area here is the main focus for this question. Alright, before we proceed to x bar and y bar, we have to first start off with the 3 small steps here, finding the x curve and y curve. Well, the y curve will always be y, because take this example here, this dot, so it only goes up directly from the x-axis. So this is your y over here. So then x curve will be different, because x curve will be the center or the middle of this distance between e and the curve, plus here the space between the curve and the y-axis. So it will be e minus the function over here plus x, which will eventually give you e plus e to the y over 2. So alright, now that we have gotten x curve and y curve, we proceed to get dA, which is the product of height and base. Height in this case will be dy, then base would be the distance here between e and the function, the curve over here. So it will be e minus the function, giving you e minus e to the y. And with dA, now we can find dm, which is density times dA. And density being a constant here, times dA will be dy, e minus e to the y. And with all this right now, we can proceed to find the x bar and the y bar of this region over here. X bar, as we know, x bar will be integration of the product of x curve and dm to dm over dm, sorry. So then it may be a bit tedious for this part, but then as you go along and be careful of what you do, be careful of the integrations and the multiplications, you won't have any problem with it. So alright, first of all, to make things easier, we take out the half over here, because since it's a constant, and then we let densities cancel each other out. And after multiplying these two, we get a line equation e squared minus e to the power y plus 1 plus e to the power y plus 1 minus e to the 2y. So this would give us a 0 over here, and then we end up with e squared minus e to the power of 2y. So then integrating this part would be, you have to be careful, because integrating ey to dy will give you ey, when integrating e to the power of 2y to respect of dy will give you half e to the power of 2y. So then there you have it, half e to the power of 2y. And then the others will be simpler, because e squared, integrating it will give you a e square y, while the denominator will almost be the same as here, ey e to the power of y, integrated you get e to the power of y. So alright, here comes the tricky part, because most people think that the limit, one of the limits is 0, would tend to ignore the 0. But then over here it would be a big mistake, because e to the power of 0 will give you a 1. So most people would think that subtracting the 1 over here will give you a denominator of 0, but it's actually not, because don't forget that you have to subtract the e to the power of 0, which is 1, and that will give you a denominator of 1. And then over here, solving it, also don't remember the limit of 0, and then subtracting everything in, you get a x bar of e squared plus 1 over 4. So now for the y bar over here, so again, y bar is the integration of y's curl and dm over integration of dm over here. So then to make things easier right now, since we have done x bar, the denominator is the same and it'll give you 1. So alright, we can just ignore the denominator for from now on, and then the numerator will be easy because multiplying y in will be simple. It will give you a ey minus ye to the power of y. But then here comes the challenge, because you are to integrate ye to the power of y, which would require some advanced integrating skills, which is by parts that we have learned in chapter 8. So alright, by parts here, to make things simple, which is sort of like a shortcut, this is the table over here, d to dy and integration. It will be y, and then you get a 1 and a 0 over here, and ey will probably be ey, and ey. So you know how this goes. It goes down like this. You have a positive here, negative here, positive here. I really hope you guys remember your integrating skills, and you end up with y e to the power of y minus e to the power of y. And then so you have this right now. Be careful of the minus, the signs here, minus, you get a plus. And then again, don't forget that e to the power of 0 is equals to 1 over here, so you don't get a 0 for that. And then after subtracting everything in, be careful because you get a 1 over here, and then you get half e minus e plus e, which will give you a 0, minus 1, which will give you a y bar of half e minus 1. And therefore we could conclude that the centroid of the area over there would be e squared plus 1 over 4 and half e minus 1, which would be the coordinate for the center of mass. And if you were to sub in e, which is Euler's number 2.71828, if I could remember, well, you eventually get a coordinate that is somewhere around here in this region. It's included over here, and which proves that your answer is valid. So by that logic, you could also use the same method by subtracting in the coordinates and then finding whether your answer is correct or not, whether it's included in the region that is shaded over there, which is focus of the question. And with that, I would like to conclude my video. Thank you.